Hello, welcome to the Learn English Lab. Today's podcast, English Listening Practice Podcast. Topic name is 35 Plus C1 Level Geography Vocabulary. We're diving into, a really fascinating exploration today. High-level geography vocabulary. And the idea isn't just, recognizing words on a page. It's more about getting a real grip on how they're used, their nuances.
Exactly. There's subtle implications.
Right. To really enrich your understanding of the world, our goal, like always, is to get you well-informed and pretty quickly cutting straight to what matters.
And that really is the core of it. For you listening in, maybe you're prepping for an exam, maybe you need this for work.
Or just curious.
Or just plain curious, yeah. Getting this depth of vocabulary, it's genuinely valuable, lets you talk and think about geography with more clarity, more impact.
It elevates the conversation, doesn't it?
It really does. It boosts your descriptive power, your analytical skills.
I totally agree.
Yeah.
And we've carefully picked this material, key ideas from physical geography, human geography.
The important stuff.
Yeah. And we've grouped it thematically. Hopefully that makes it easier to follow and crucially helps you remember these terms, what they really mean.
Provides a pathway, a structure.
Okay, let's unpack this. The power of precise geographic language. So first off, why is this C1 level vocabulary so important, specifically in geography? You might think, okay, I know river, I know mountain.
The basics, sure.
But this is about going beyond that, isn't it? It's the ability to use words with real precision, with depth. It allows for, much more sophisticated descriptions, sharper analysis.
That's a key distinction, moving beyond just spotting a feature to actually understanding the forces behind it, the relationships.
Right, the dynamics.
Exactly. Proficiency at this C1 level, it's a big leap. It's not just knowing the word, it's applying it accurately in different contexts, sometimes really complex ones.
It shows a deeper understanding.
A much deeper comprehension, yeah. Knowing the difference between, say, a bay and a cove, not just size, but maybe formation or function, or grasping why a plateau isn't just a flat plane high up.
The nuance.
It's all nuance. It lets you describe not just what is there, but why it matters, how it works, how it fits into the bigger picture, the Earth system.
And the practical side of this.
Yeah.
It's huge. I mean, obviously for exams like IELTS or the Cambridge C1 Advanced, that kind of precision gets rewarded.
Definitely.
But maybe more broadly, just think about describing the natural world better. Or how humans in the environment interact those complex, sometimes difficult relationships. Being able to talk accurately about, say, coastal erosion, or the risks on a deltaic plain, or why river valleys are fertile, using the right words makes your points much stronger.
More compelling, more authoritative.
Yeah, exactly.
More persuasive.
And it connects everything. Geography isn't really in a silo, is it? It bumps up against ecology, economics, history, politics, even engineering.
Constantly intersecting.
All the time.
Yeah.
So when you can talk precisely about geographical things like the flow of a river, it unlocks understanding in those other fields too.
River flow isn't just about water moving. It affects farming, trade routes historically, settlement patterns, even, political relationships over centuries.
Wow, okay. So these words are like keys.
Exactly. Finely tuned keys to unlock a broader, more integrated knowledge of our planet and how we fit into it.
Got it. So to guide everyone through this, we've structured things into 5 main themes. First up is measurements and positions, basically how we locate things on Earth.
The fundamentals.
Then we'll jump into water-related features, how water shapes everything. After that, landforms and terrains, the solid stuff.
Mountains, plains, that sort of thing.
Then atmospheric and environmental processes, the forces of change. And finally, we'll look at some key descriptive adjectives and adverbs.
The words that add the color in detail.
Right. Tools to make descriptions richer. That structure should give us a clear path, measurements and positions, pinpointing our world. Okay, let's start right at the core. How do we define where things are, measure distance, orient ourselves? It really begins with a few key terms.
Absolutely. And the first one is altitude. Now, this is a noun, and it basically means the vertical distance, how high up something is, measured usually from mean sea level.
Right, the baseline.
The baseline. You might hear elevation or height used sometimes, but altitude implies that precise measurement from a reference point.
And it has so many applications. Think about mountaineers. They have to acclimatize to high altitude, right?
Yeah.
To avoid altitude sickness.
It's a physiological necessity.
It's not just being tired. It's the thin air, the pressure affecting your body.
Profoundly.
Or in aviation, pilots are constantly monitoring altitude. That's crucial for safety, avoiding obstacles, dealing with weather.
Absolutely paramount.
And even broader, climate scientists study altitude variations. Because why? It determines vegetation zones, right? Different plants grow at different heights.
Directly. Temperature, pressure, it all changes with altitude, creating distinct ecological bands up a mountainside.
So altitude isn't just a number, it's like an environmental gradient. It creates microclimates, affects biodiversity.
Precisely. It's fundamental. Aeronautics, environmental science. Understanding altitude is key to understanding how these vertical systems work on our planet.
Okay, so that's vertical.
Okay.
Now let's pivot to horizontal. Latitude?
Right, latitude. This is the angular distance measured in degrees, north or south of the equator. 0 degrees is the equator, 90 degrees is the north or south pole.
Our north-south position.
Exactly. Often called a parallel because lines of latitude run parallel to the equator.
And this single coordinate, it dictates so much. Like the Tropic of Cancer, that latitude, about 23.5 degrees north.
Defines a major climate zone.
Yeah. Influences sunlight intensity, temperature, weather patterns, everything. It's why plants in really high latitudes have adapted to those long summer days and long winter nights. It's a direct response to the seasonal light variation at that latitude.
Remarkable adaptation.
And historically, of course, navigators use latitude, along with longitude, to pinpoint locations on maps, essential for exploration, trade.
Absolutely vital. So the key thing about latitude is it doesn't just tell you where you are north-south. It fundamentally shapes climate, biodiversity, farming possibilities.
Even where people settle.
Absolutely. Human settlement patterns are heavily influenced by latitude and the conditions it creates.
Wow. Okay, so latitude is a primary driver of life on Earth.
You could say that. From rainforests near the equator to ice caps at the poles, latitude helps us understand these broad environmental bands.
All right, so the complement to latitude, giving us our east-west position, is longitude.
Exactly. Longitude is the angular distance, again in degrees, east or west of the prime meridian.
Which runs through Greenwich, England.
That's when the 0-degree reference line, so longitude lines or meridians, run from pole to pole. It's our east-west coordinate.
And longitude.
Yeah.
It's so tied into our daily lives, maybe more than we realize. That prime meridian in Greenwich, it's the global reference for time, too. And the differences in longitude directly create our time zones. Why it's morning here and night somewhere else.
Affects global communication, travel, everything.
Absolutely. And historically. Figuring out longitude accurately at sea was a massive challenge.
Huge scientific problem for centuries.
Explorers needed those special clocks, chronometers, to work it out.
Yeah.
It revolutionized maritime navigation.
Allowed for accurate mapping of the world. So the deeper insight with longitude, it's not just lines on a map, it's the grid that underpins our globalized world. Time zones, GPS, historical exploration.
It enables it all.
It connects it all, from coordinating global finance to understanding how explorers map the planet. It's the invisible grid.
Okay, shifting from coordinates to something more. Visual. The boundary we see. Let's talk about the horizon.
The horizon. That line where the sky seems to meet the earth or the sea, you might call it the skyline or vista boundary.
It seems simple, but it's so significant.
It is. While it's an apparent line affected by your height and the earth's curve, it has huge practical and symbolic meaning.
Sailors, for centuries, scanned the horizon, looking for storms, looking for land.
Critical for weather watching, navigation at sea.
Or if you're on a mountaintop, that horizon stretching out gives you that sense of scale, of vastness.
Perspective. Yeah.
And photographers, artists, they love the horizon, especially at sunrise or sunset, when the sun dips below or comes up.
It marks the passage of time, day to night. It's aesthetically powerful, even has links to basic astronomy.
So the horizon shapes how we move, how we understand our environment, even how we represent space in art.
That's a great way to put it. Its significance goes beyond just seeing. Navigation, art, even psychology, feelings of freedom, limits. It's the visible edge of our world from where we stand.
And finally, for this section on measurements and positions.
Yeah.
The pole.
The pole. As a noun in geography, this means the northernmost or southernmost point on Earth, where the planet's axis of rotation meets the surface.
The extremity.
The polar points.
And they're fascinating places, like the North Pole isn't land, right? It's shifting sea ice.
Correct. Common misconception. It's a dynamic ice cap over the Arctic Ocean. Very fragile.
Whereas the South Pole is on a continent, Antarctica. But expeditions there face unbelievable cold isolation.
Extreme challenges, logistically incredibly difficult.
And another thing, compasses get unreliable near the poles.
Very unreliable. Because of how Earth's magnetic field converges there, it makes standard navigation tricky. You need other methods.
So the poles aren't just dots on a map. They're critical climate regulators, dynamic zones.
Absolutely. They have unique environmental significance. They regulate global climate, host specialized ecosystems, and are vital frontiers for science studying past climate future changes. They're extreme, yes, but their influence is global.
The lifeblood of landscapes.
All right, let's shift gears now. Let's talk water. From huge oceans to tiny ponds, water is constantly sculpting our landscapes, both natural and human.
Absolutely pivotal role.
Yeah, this is where it gets really interesting, I think, how these features shape the earth and influence life.
Okay, first up, bay. A bay is generally an area where the coast curves inward, enclosing a part of the sea, usually broader and more open than, say, a cove.
An indentation in the coastline.
Pretty much. You might hear inlet or embayment, but bay is common for these larger features.
And they can be incredibly important. San Francisco Bay, huge for shipping, tourism.
Great example of economic and recreational significance.
And marine life often thrives in bays, right? Because the water's more sheltered than the open sea.
Exactly. They often serve as crucial nurseries for fish, habitats for birds, protected ecosystems.
And over long periods, erosion can actually make bays bigger.
Oh yes. Coastal processes are always at work, reshaping shorelines, widening bays. It shows that geomorphology in action.
So the deeper point is that bays often become focal points for both nature and human development.
That's a critical tension. They are transition zones, ecotones, ideal for ports, cities. But this concentration of activity puts pressure on those unique ecosystems. Management becomes key.
Okay, moving inland a bit to rivers. What about a branch?
A branch is a smaller part of a river that separates from the main channel. It might rejoin it later or flow off somewhere else.
Like an offshoot.
An offshoot, an arm.
Yeah.
Not necessarily a tributary, which flows into the main river.
Right.
A branch flows out or alongside.
You see this in big river systems. The Mississippi Delta has lots of branches, right?
Classic example. Creates that complex delta landscape, crucial for ecology and navigation.
Or someone canoeing might explore a quiet branch of the Amazon, looking for wildlife.
Shows how these smaller channels offer access to different, sometimes more remote parts of the ecosystem.
But they can also be vulnerable. Lower branches often get flooded.
Disproportionately so. They're often in low-lying areas, making flood control and water management critical, especially near towns or cities.
So rivers aren't just straight lines, they're networks. Branches distribute water, sediment.
Connect the whole basin. Understanding that branching is essential to understanding how the whole river system works and affects the surrounding land.
Got it. Now, a smaller coastal feature, the cove.
Ah, a cove.
Well,
It's like a small bay, often more secluded, more sheltered, a little nook or recess in the coastline, usually curved.
Smaller scale, but interesting history sometimes, like smugglers using hidden coves.
Exactly. That historical context is fascinating. Their seclusion made them ideal for illicit activities, evading authorities.
And practically, a rocky cove offers safe anchorage for small boats, protection from the open sea.
Definitely. That natural shelter is a key characteristic.
And for adventure, divers might explore underwater caves in a cove.
Yeah. Links into tourism, marine exploration, discovering hidden geology.
So coves, despite being small, create these unique microenvironments and have shaped local stories.
That's a great summary. Significant roles in history, unique microhabitats supporting distinct life, little pockets of difference along the coast.
Okay, moving to human-made structures interacting with water. The dock.
Right, a dock, a structure built out into or alongside the water. Its purpose is getting people and cargo on and off boats and ships.
Like a pier or wharf or quay.
Those are all similar terms, yes. It's essential maritime infrastructure.
And docks are hubs of activity. Huge cargo ships unloading in Rotterdam.
Shows their vital role in global trade, port logistics.
Or on a smaller scale, fishermen repairing nets on a wooden dock.
Depicts everyday coastal livelihoods, that direct connection to the sea.
And tourists boarding ferries from a dock.
Highlights their role in transport, leisure, connecting land and water activities.
So a dock isn't just wood or concrete, it's a node in supply chains, a lifeline for communities, a point of interaction.
Absolutely. Vital infrastructure connecting land-based economies to the global maritime network. Gateways for commerce and culture.
Now, a really important transitional zone, ecologically speaking, the estuary.
Yes, estuaries are crucial. They're semi-enclosed coastal bodies where fresh water from rivers mixes with salt water from the ocean.
Where the river meets the sea, basically, often wide, maybe funnel-shaped.
Exactly, sometimes called a river mouth, tidal inlet, or firth. That mixing creates a unique, dynamic environment, brackish water.
And they are incredibly important. The Thames estuary, vital for migratory birds.
Huge wetland habitats. Links estuaries to global conservation, bird populations.
But they're also vulnerable. Pollution from upstream ends up in the estuary.
Very much so. Industrial discharge, agricultural runoff.
Yeah.
It gets concentrated there, affecting water quality, harming life. Sensitive zones.
Yet they also protect us, act as buffers against storms.
Yes, they can absorb wave energy, reduce storm surge impact further inland. A vital protective function.
So the real insight about estuaries, they're like ecological crossroads. Highly productive, but easily damaged.
Precisely. They're bellwethers of environmental health. They show the direct impact of what happens upstream on coastal marine life, and they play a big role in nutrient cycling too.
Indicators. Okay, let's think about the general idea of flow.
Flow. As a noun, it just means the state of moving constantly, steadily, usually liquids, water, air, even molten rock.
Like a current, a stream, flux.
Those are good synonyms. It describes continuous, often directed movement.
And it applies across so many scales. A river's flow increases in the rainy season. Simple enough.
Phasic, hydrology, seasonal change.
But then, lava flow from a volcano, that reshapes the land itself.
Shows it applies to geological processes too. Destructive, but also creative.
And even globally. Ocean currents and the flow of heat around the planet.
Connects it to massive climate systems, thermal energy distribution.
So flow is fundamental water, air, energy. Maybe even information or people.
It's a core principle of dynamic Earth systems, from microscopic water movement in soil to tectonic plate shifts, constant movement, energy transfer.
Got it. Okay, a larger coastal feature, often significant politically or economically, the Gulf.
A gulf, generally larger than a bay, partially surrounded by land, often with a narrower opening to the main ocean.
An arm of the sea, a bight.
Could be described that way, yes. But gulf often implies a larger scale, maybe more strategic importance.
And they often are significant. The Gulf of Mexico prone to hurricanes because the water's so warm.
Directly links the geography to specific weather patterns, natural disasters.
Or the Persian Gulf, dotted with oil rigs, a key energy resource area.
Highlights economic geography, resource extraction, global trade implications.
And the marine life in gulfs often supports big fishing industries.
Emphasizes that ecological and economic interdependence.
So gulfs aren't just shapes on a map. They're often arenas for economics, environment, geopolitics.
That's a key observation. Centers of economic activity, resource hubs, but also environmentally sensitive due to their semi-enclosed nature and concentrated human impact.
Right. Now, for something dramatic, often found in cold waters, the iceberg.
An iceberg. A very large piece of floating ice that's broken off or calved from a glacier or ice sheet.
A berg, a glacial fragment.
Exactly.
And they can be stunningly beautiful, but also incredibly dangerous. The Titanic hitting an iceberg.
The classic historical example of the navigation hazard they pose.
And now, with climate change, more icebergs are paving off glaciers.
Significantly more. It's a direct consequence of warming, glacial melt, contributing to sea level rise.
And scientists study them, because the ice contains clues about past climates.
Yes, trapped air bubbles, layers of ice. They're like frozen time capsules. Invaluable for paleoclimatology.
So, beyond just being obstacles, how else do icebergs affect the marine environment? Do they change currents or add nutrients?
That's a great question. They are indicators of planetary health for sure. Ecologically, as they melt, they release huge amounts of cold, fresh water. This can locally affect salinity and temperature, influencing currents. And importantly, they often carry fine rock dust rock flour scraped up by the glacier. As this melts out, it releases minerals and nutrients.
Fertilizing the ocean.
Effectively, yes. It can trigger phytoplankton blooms, creating temporary feeding hotspots in otherwise nutrient-poor waters, so they impact the food web significantly.
Fascinating. Okay, from the colossal iceberg down to the much smaller pond.
A pond. An area of still water, smaller than a lake, sometimes natural, often artificially made.
A pool. A small lake. A tarn in the mountains.
Those are all good synonyms.
With diverse roles. A farm pond for irrigation during dry spell.
Shows their utility in agriculture, water management.
Or frogs breeding in a shallow pond in spring.
Highlights their importance as habitats for amphibians, smaller aquatic life. Indicators of local ecosystem health.
Even decorative ponds in city parks.
Illustrates their role in landscape design, urban recreation, aesthetics, bringing nature into built environments.
So small, but significant locally.
Absolutely. Overlooked, perhaps, but crucial localized ecosystems with diverse functions influencing microclimates and local water retention.
Okay, for human water management on a much bigger scale. The reservoir.
A reservoir. A large body of water, either a natural lake used for storage, or more often, an artificial lake created by building a dam across a river.
A storage lake. An impoundment.
Right. Its main purpose is storing water for homes, irrigation, hydroelectric power.
And some are huge engineering projects. The Hoover Dam creating Lake Mead.
Classic example. Shows the scale of engineering involved, providing water and power for vast areas.
But they're vulnerable too. Droughts lowering water levels in a city's reservoir.
Directly connects them to climate impacts, water security challenges for cities, and agriculture.
And they're often used for recreation too. Stocked with fish for angling.
Highlights their multifunctional use utility plus recreation, like boating, fishing, swimming.
So a reservoir is complex. Infrastructure, resource, recreation. But with ecological consequences too.
Definitely. They play a critical role in modern society for water, energy, flood control. But building them alters river systems, traps sediment, can displace people. It involves complex trade-offs.
Right. Okay, last one in this water section. The swamp, a unique wetland.
Yes, a swamp. An area of low-lying land, permanently or seasonally wet, typically dominated by trees and shrubs.
Different from a marsh, which is more grassy, or a bog, which is peaty and acidic.
Exactly. Those are related types of wetlands, but swamp implies woody vegetation in wet conditions.
Often seen as murky or dangerous, but they're ecologically rich, like the Everglades.
Incredibly rich, home to unique species like alligators, diverse plants, vital biodiversity hotspots.
But historically, swamps were often drained for farming or building.
Yes, and that can lead to major problems. Soil subsidence, loss of natural flood control, habitat destruction.
And, well, mosquitoes do like swamps.
That's true. The humid conditions are ideal, which can link swamps to public health concerns, vector-borne diseases, a challenge for nearby populations.
So the C1 understanding is seeing past the murky image to their vital ecological roles, water purification, carbon storage, even if they've often been misunderstood or destroyed.
That's the key point. Ecologically vital, acting as natural filters, flood regulators, carbon sinks, but incredibly vulnerable to human activity, making their conservation really important. Landforms and terrains, sculpting the Earth's surface.
Okay, let's shift from water to solid ground now. The landforms, the terrains that make up the planet's surface, towering mountains, flat plains, these tell the story of Earth's geology.
The physical structures.
Exactly. So what does this all mean for the land itself? How do we categorize these features?
Let's start with something fairly simple. A clearing. It's basically an open, treeless area within a forest or woodland.
A glade, an opening, a meadow if it's grassy.
Those are all good ways to think of it.
And they can be natural places or made by people, hikers resting in a sunny clearing.
A natural pause point, a scenic spot.
Or wildlife gathering there, especially at dawn or dusk.
Very common. Links clearings to animal behavior, foraging, part of the forest ecosystem.
But also loggers creating a large clearing for timber.
Addresses the human impact. The changes we make to forested landscapes can lead to habitat fragmentation.
So clearings are like windows in the forest, showing ecology, human interaction.
Dynamic spaces, definitely.
Right.
Shaped by natural events, tree falls, fires, and human actions. They affect light, vegetation, animal habitats locally.
Okay, now for something much more dramatic. The crater.
A crater, usually a large bowl-shaped hole in the ground, most commonly at the top of a volcano.
Or from a meteorite impact.
Or from an impact, yes.
Yeah.
A very large volcanic one might be called a caldera, or just a pit or volcanic mouth.
And they can be active or dormant. Kilauea in Hawaii, constantly emitting steam and gas.
Shows active volcanism, ongoing geological processes reshaping the land right now.
But craters aren't just on Earth, right? The moon is covered in impact craters.
Extends the concept of planetary science, extraterrestrial geography, evidence of the solar system's history.
And people visit them, hiking to the edge of a dormant crater like Crater Lake. Geotourism.
Offers amazing views, insights into past geological power.
So craters are direct evidence of massive forces, volcanic or impact, shaping planets.
Vividly. They reveal immense power, both internal to a planet and external from space, offer unique windows into planetary processes and history.
Thinking about how land builds up. Deposit.
A deposit.
Yeah.
As a noun, it's a layer of material sediment, rock fragments, ash that is accumulated, usually carried and then dropped by water, wind, ice, or volcanic activity.
An accumulation, a layer, sediment.
Those are the key ideas.
And deposits are fundamental. River deposits create fertile deltas like the Niles, crucial for farming, ancient civilizations.
Absolutely. Rich soil formation, agricultural productivity.
Or glacial deposits, the stuff left behind by ancient ice sheets. Tells us about past ice ages.
Invaluable evidence for geological history. Climate change over millennia.
And economically, mineral deposits attract mining.
Directly links geology to economic resources, industrial activity.
So deposit isn't just stuff piling up. It's about the process of deposition, what it tells us historically, and its resource value.
That's the C1 nuance. Exactly. Understanding the process, the historical record, the economic potential. It's key to soil science, resource management, geology.
Okay. The classic mountain feature. The peak.
The peak. The pointed top of a mountain.
Summit. Apex. Pinnacle.
All good synonyms. The highest point.
And peaks symbolize height, challenge, beauty. Mount Everest's peak, the highest on Earth.
The ultimate example of extreme elevation.
And snow often stays on a mountain peak all year.
Describes those harsh, high-altitude climate conditions. Below freezing even in summer.
And climbers reaching the peak. It's a symbol of achievement, right? Adventure, endurance.
Huge symbolic power. Portrays the drive for exploration, overcoming challenges.
So a peak isn't just a point. It's geology, ecology, and culture all meeting at the top.
Well put. A culmination of forces, a unique environment, and often a powerful human symbol. Represents extremes, challenges, and achievements.
All right, broadening out to larger landforms. One partly surrounded by water, the peninsula.
A peninsula. A piece of land mostly surrounded by water but still connected to a larger mainland on one side.
Like a cape or promontory, but usually bigger.
Generally, yes. Cape often implies a smaller, more pointed feature.
And peninsulas can be distinct regions. The Iberian Peninsula, Spain, and Portugal.
Shows them as significant geographical units with their own histories, climates, cultures, often shaped by that maritime influence.
And wildlife on a peninsula can be isolated, leading to unique species.
Yes, the water acts as a barrier, influencing biodiversity, sometimes leading to endemism.
But they can also be vulnerable. Coastal erosion threatening homes on a narrow peninsula.
Addresses their environmental risks, especially with storms and sea level rise.
So the geography of a peninsula fosters unique ecosystems, cultures, but also specific vulnerabilities.
That's the core idea. Their partial isolation influences climate, life, human settlement, creating distinct zones, sometimes barriers, sometimes bridges.
Okay, from high points and peninsulas to the vast flat areas.
The plain.
An extensive area of flat or gently rolling land.
Flatland, prairie in North America, steppe in Eurasia.
Exactly. Those terms specify types of plains based on vegetation or location.
And plains have been crucial for humans. The Great Plains in the U.S., huge for farming, ranching.
Ties plains directly to agricultural productivity, global food supplies, bread baskets.
Or nomadic herders crossing African plains for centuries.
Focuses on human adaptation to these open spaces, cultural contexts of movement, resource use.
But flatness has downsides too. Low-lying plains often flood.
Explains the hydrological risks. Water spreads easily with nowhere to drain quickly. Impacts large areas.
So a plain offers potential farming, movement, but also vulnerability. A place for adaptation. Very much so. Significant for agriculture, migration, civilizations. But vulnerable to floods, erosion, sometimes desertification. Requires careful management.
Another type of flatland, but elevated. The plateau.
A plateau. An area of relatively flat land that's significantly higher than the surrounding areas, often with steep sides.
Tableland. Mesa, if it's smaller and isolated. Upland.
Those are all related terms. Key is flat and elevated.
And they can have dramatic scenery. The Colorado Plateau canyons, arches carved by erosion.
Iconic landforms shows erosional geography at work on a grand scale.
But farming on a plateau can be tough. Often needs irrigation because it's high and maybe dry.
Addresses the water challenges in these elevated environments.
And ancient civilizations sometimes lived on high plateaus, like in the Andes or Tibet.
Links plateaus to history, maybe seeking defense, cooler climates, or isolation. Strategic locations.
So the C1 nuance for plateau is that combination. High elevation plus flat terrain creates unique conditions, different from mountains or plains.
Excellent distinction. Combines elevation advantages, cooler temps, defense, with flat land utility. leads to specific climates, hydrology, geology, and human adaptations.
Got it. Now, for lines of mountains, the range.
A range, a line or chain of mountains or hills connected by high ground, usually formed by the same geological process.
A chain, ridge, sierra.
Yes, Sierra, particularly in Spanish-speaking regions.
And ranges can be huge. The Andes spanning multiple countries in South America.
Shows them as continental scale features influencing climate, biodiversity, culture across vast areas.
And economically, ski resorts in the Alps.
Highlights the recreational economy tied to mountain ranges, tourism.
And they form because of tectonic activity, plates colliding.
Explains their geological origin. Earth's plates pushing together, folding, uplifting the crust.
So a range is evidence of massive geological power and acts as a barrier or corridor for climate, life, and people.
Indeed. Direct results of tectonics. They act as climate barriers, shape weather, influence migration, settlement, living proof of a dynamic planet.
Okay, a smaller, narrow feature, often carved by water. The ravine.
A ravine. A deep, narrow valley with steep sides, usually worn down over time by a stream or river.
Smaller than a gorge or canyon? Maybe called a gully if it's really small.
Generally, yes, though the terms can overlap. Key is deep, narrow, steep-sided, water-carved.
And they can form quickly sometimes. Flash floods in dry areas, carving them deeper.
Shows intense erosion in action, especially in arid landscapes where sudden downpours have immense power.
And hiking in a ravine needs caution. Steep, maybe unstable.
Emphasizes safety in rugged terrain.
But life finds a way. Vegetation clinging to the shaded walls.
Connects ravines to microhabitats. Sheltered, often moist conditions can support specific plants and animals.
So ravines show erosion powerfully, create complex microenvironments, and can be barriers or pathways.
Exactly. Tangible examples of erosion sculpting the land, creating diverse, often challenging environments that influence access, ecology, microclimate.
Similar to peak, but maybe with a slightly different feel. Summit.
Summit. The highest point of a mountain or hill. Like peak, crest, apex.
Often used interchangeably.
Often, yes.
Yeah.
But summit sometimes carries a stronger sense of arrival, achievement, the goal of a climb.
And reaching a summit, it's physically demanding. Thin oxygen at high altitude.
Links summits to those extreme atmospheric challenges for climbers. Requires adaptation, gear.
And flags or cairns marking the summit symbolizes conquest, exploration.
Portrays that narrative of mountaineering triumphs, overcoming natural barriers.
So a summit isn't just a location, it's where geology, extreme ecology, and human ambition meet.
Well said. Physical and psychological significance. Represents the culmination of effort, exploration, science, personal challenge. Offers unique perspectives, data, and a sense of accomplishment.
And lastly, for landforms, a unique cold environment. The tundra.
The tundra. Expansive, flat, treeless regions, mostly in the Arctic or high mountains. Alpine tundra, key feature. The subsoil is permanently frozen permafrost.
A permafrost plain, Arctic desert, frozen steppe.
Those descriptions fit, but tundra is the specific biome name.
And life there is tough, but resilient. Caribou migrating across vast distances.
Illustrates incredible animal adaptations to harsh conditions, dramatic seasonal changes.
But it's fragile. Oil exploration threatens the tundra ecosystem.
Addresses those critical human-environment conflicts in sensitive regions, resource extraction impacts.
And the big worry now. The permafrost is thawing because of global warming.
Ties tundra directly to major climate change indicators. Thawing releases vast amounts of stored greenhouse gases like methane and CO2.
Feedback loop.
A critical, dangerous feedback loop. So the C1 understanding of tundra, not just cold, but a key climate regulator, a sensitive indicator of planetary health, holding vast stores of carbon.
Okay, that fragility is key.
Absolutely. Unique, fragile, vital role in global climate. Its vulnerability makes it a critical area for study and conservation, atmospheric and environmental processes, forces of change.
We've looked at locations, water features, landforms. Now let's talk about the processes. The forces that are constantly changing things, reshaping the planet's surface and atmosphere.
The dynamic actions.
Yeah. This gets to how the environment itself evolves over different timescales. These are the verbs of geography, in a way.
That's a good way to think about it. And perhaps the most fundamental process is to erode. It's a verb.
Meaning to wear away.
Exactly. Natural forces, wind, water, ice, gravity, gradually wearing away or carrying off surface material, like abrading or corroding.
And we see erosion everywhere. Rivers carving canyons over millions of years.
Shows the immense power of water erosion over geological time. Grand Canyon is the classic example.
Or wind blowing away topsoil, especially if forests are cut down.
Highlights wind erosion, soil degradation, especially when vegetation is removed, can lead to dust bowls, desertification.
And even acid rain damaging buildings, historical monuments.
Links erosion to human pollution. Shows how our activities can accelerate these natural processes with costly consequences.
So erosion is this constant interplay. Natural forces, sometimes accelerated by human actions, reshaping everything.
Precisely. A fundamental geological and environmental process with both natural and human-driven causes and significant impacts on landscapes, ecosystems, farming, infrastructure. Understanding it is vital for resource management, hazard mitigation, descriptive adjectives and adverbs, adding depth and detail.
Okay, now for our last group. These aren't nouns naming things, but adjectives and adverbs. The words that let us describe features and processes with more. Color. More precision.
Nuance and detail. They bring the descriptions to life, paint a much richer picture. Essential tools.
Right. First one, arid. An adjective.
Arid means very dry. Land or climate with very little or no rain. Think parched or desiccated. It's about a fundamental lack of moisture.
And arid places pose challenges, but also foster unique adaptations. Camels surviving in deserts.
Classic biological adaptation to extreme water scarcity.
But humans adapt too. Irrigation turning arid lands into farms.
Shows human ingenuity overcoming natural limits, transforming landscapes for agriculture.
Though worryingly, arid zones are expanding. Desertification.
Links aridity to global environmental change, climate impacts, land degradation. A growing challenge.
So arid isn't just dry, it's a whole climatic state with ecological and geopolitical consequences.
Exactly. Defines vast regions, poses huge challenges for water, food security, ecosystem management, and a warming world.
Okay. Similar, but focused on productivity. Barren.
Barren. Adjective meaning land or soil that can't produce plants well, or maybe at all. Infertile, sterile, unproductive, lacks life-supporting capacity.
And landscapes can become barren naturally, or because of us. Volcanic ash making land barren initially.
Describes that immediate post-eruption state before soil develops and life returns.
Or mining, leaving behind barren pits and waste heaps.
Contextualizes industrial impacts, environmental damage, often long-lasting scars.
But it's not always permanent. Restoration efforts trying to green barren hillsides.
Emphasizes ecological rehabilitation, human efforts to heal damaged land.
So barrenness is a state natural or human-caused, and represents a challenge, but maybe also a possibility for restoration.
Good point. It can be natural. Polar regions, high mountains, or human-induced deforestation, mining. Restoring these areas is a major focus of ecological science and conservation.
Right, a very common geographical adjective, coastal.
Coastal, relating to or located along the coast, that dynamic zone where land meets the sea.
Shoreline, littoral, seaside.
All related terms. It describes that interface.
And coastal areas are dynamic, often crowded, and face unique issues. Coastal erosion threatening homes.
Addresses those active processes, the land-sea boundary, and the risks to settlements.
And cities like Miami facing sea level rise.
Links coastal areas directly to major climate vulnerabilities, the need for adaptation.
Yet coastal ecosystems like mangroves or reefs are incredibly rich in life.
Highlights the immense ecological value, biodiversity hotspots, crucial nursery grounds, protective barriers.
So coastal implies this complex active zone, high energy, high human pressure, high ecological value, high vulnerability. We hear about coastal squeeze too.
Yes, that's a key concept. Rising sea levels, pushing habitats against fixed sea defenses, shrinking or eliminating them. And the debates around managed retreat versus building higher walls. Huge socioeconomic implications.
Complex indeed.
Very. Coastal zones are critical areas. Intense processes, concentrated human activity, vital ecosystems, all under pressure from climate change and development. Needs integrated management.
Okay, the opposite of barren, fertile.
Fertile, an adjective for land or soil that can produce abundant crops or plants. Productive, rich, fecund, high natural productivity.
And fertile land shaped history, the Nile Valley supporting ancient Egypt.
Ties fertility directly to the rise of civilizations, agricultural wealth.
Surprisingly, volcanic eruptions can sometimes make land more fertile. The ash.
Yes, volcanic ash, once weathered, can add vital minerals, enriching the soil. A geological benefit.
But we can ruin it too, over-farming, depleting fertile fields.
A stark warning about unsustainable practices degrading this precious resource, leading to soil loss, potentially desertification.
So fertile isn't just about potential, but also the need to maintain that potential sustainably.
That's the critical connection. Fertile land is foundational, but finite. Maintaining its productivity sustainably is essential for future food security.
Okay, moving away from the sea. Inland.
Inland. Adjective meaning located away from the coast in the interior of a country or continent.
Interior, landlocked, continental.
Exactly. Signifies separation from maritime influence.
And inland areas have distinct characteristics. Inland seas, like the Caspian, isolated from oceans.
Clarifies those geographical anomalies. Large water bodies surrounded by land with unique hydrology and ecology.
And inland temperatures swing more wildly. Hotter summers, colder winters than coastal areas.
Contrasts with the moderating effect of the ocean. Continental climates are more extreme.
And historically, inland trade routes connected empires, crossing land, not sea.
Addresses historical economic geography, how commerce and culture moved across continents.
So inland implies distinct climates, histories, economies shaped by that distance from the sea.
Precisely. Different weather patterns, unique biodiversity sometimes, different settlement histories and resource use compared to coastal regions.
Okay, now venturing out to sea, away from the coast, offshore.
Offshore, adjective meaning situated or occurring in the sea, but away from the shore.
Seaward, marine, but more distant. Pelagic for the open ocean.
Those terms help specify. Offshore implies distance from the immediate coast.
And offshore areas are increasingly important. Offshore wind farms generating renewable energy.
Shows modern uses, sustainable development, harnessing sea winds.
But also risks. Oil spills from offshore rigs causing huge damage.
Contextualizes the environmental hazards of resource extraction at sea.
And offshore islands can have unique species because they're isolated.
Highlights biogeography, how isolation drives evolution, creates endemic species.
So offshore is a frontier for resources, energy, biodiversity, but needs careful management.
That's the balance. Critical for resources and conservation, but human interaction there brings complex challenges for environmental protection and sustainability.
Related, but broader. Marine.
Marine. Adjective relating to the sea or ocean in general. Its life, its processes.
Oceanic, aquatic, nautical.
All synonyms pointing towards the sea environment.
Yeah.
Encompasses everything from the surface to the deep seabed.
And marine environments are vital. Marine protected areas conserving coral reefs.
Emphasizes conservation efforts for these critical ocean habitats.
And marine currents distributing heat and nutrients globally.
Describes those fundamental oceanographic processes that drive climate and marine food webs.
But pollution is a massive threat. Plastics, chemicals affecting marine ecosystems.
Addresses the huge human impacts on the seas, threatening biodiversity and potentially our own health.
So marine isn't just sea stuff. It's recognizing the ocean as this vast, interconnected system, vital for the planet, but under immense pressure.
Couldn't agree more. Vital for climate, biodiversity, human life. Complex systems facing unprecedented threats. Study and protection are paramount.
Thinking about places relative to each other. Neighboring.
Neighboring. Adjective, describing a place that's geographically close to another, often sharing a border.
Adjacent. Nearby. Contiguous.
Right. Signifies proximity and often interconnection.
And proximity matters. Neighboring countries sharing a river basin, like the Danube.
Shows transboundary features requiring international cooperation for management.
Or earthquakes affecting neighboring areas.
Contextualizes how geological events don't respect borders, ripple outwards. Seismic interconnectedness.
And economically, trade often thrives between neighboring towns.
Ties proximity to economic interaction, local markets, shared resources, easy transport.
So neighboring isn't just closeness, it's about the web of shared influences, dependencies, challenges that result from being near each other.
That's a critical point. Proximity shapes human and physical geography profoundly. Resource sharing, economic ties, disaster impacts, cultural exchange, conflict. It's all influenced by who your neighbors are. Key for planning, relations.
And finally, a directional adverb, often used with rivers. Upstream.
Upstream. Adverb meaning against the current of a river or stream, moving towards the source.
Upriver. Against the flow. Headward.
Those all capture the meaning, opposite to the direction the water's flowing.
And this directionality is crucial. Salmon swimming upstream to spawn.
Illustrates biological migrations, life cycles tied to river flow direction, Incredible journeys.
But conversely, pollution travels downstream from upstream sources.
Contrasts the directions. Highlights interconnectedness and environmental problems. What happens upstream affects everything downstream. Need for source control.
And explorers paddling upstream. That sounds hard.
Depicts the challenges of river navigation against the current. Requires more effort, different strategies.
So upstream is key for understanding cause and effect in river systems, ecology, pollution, history.
Absolutely vital. The directional flow dictates so much. Ecosystem health, human impacts, environmental management. You have to consider the whole basin upstream and downstream for it to make sense.
Wow. We have really covered a lot of gear today, haven't we? Or maybe covered a lot of water and landforms.
Chuckles indeed. From peaks to ravines, arid deserts to fertile plains.
Altitude, latitude, flow. It's a rich vocabulary. And hopefully everyone listening now has a better toolkit to describe and understand our world.
That's the goal. Because connecting this to the bigger picture, it helps you see the world less as just a collection of places and more as this dynamic, interconnected system.
Processes and features constantly interacting.
Exactly. Each word we looked at unlocks a deeper layer, helps appreciate those complexities, those interdependencies shaping the planet. It enriches your mental map.
So what does this all mean for you listening? Well, we really hope you'll start using this vocabulary. When you watch a documentary, read the news, even just look outside.
Try to spot these terms in action.
Yeah. Challenge yourself. Can you describe what you see with this newfound precision?
And maybe a final thought to chew on. Think about how just a small shift in one feature, maybe a plain becoming more arid or the flow changing in a river's estuary.
How that could ripple through the whole neighboring region.
Exactly. What could that mean for the local climate, for biodiversity, for human activity, farming, water resources, maybe even migration patterns down the line?
Big interconnected questions.
The kind of questions this deeper geographical vocabulary helps us ask and maybe start to answer.
Thank you so much for joining us on this deep dive today. We hope you enjoyed expanding your geographical lexicon and getting a richer feel for our amazing planet. And please do remember to like, share, and subscribe to this YouTube channel for more deep dives into fascinating topics.